All right, let's get to some homework. This is 7-1, attributes of exponential functions. Alrighty, let's look at number 1. Number 1 tells us to complete the table of values for each function, then graph the function and find the minimum and maximum values on the interval -3 to 3. Alright, we're going to look at number 1, and then you can do number 2 or number 3, whichever one you need to do for homework. You can do those on your own. Let's look at our table. First of all, we've got x, we've got 3 to the x power, and then we have y. And they've already filled out the -2 for us. So we're going to go -2, -1, 0, 1, 2. And let's just fill out the 3 to the x power, and then we'll do the y's. Okay, so we have 3 to the -2, we have 3 to the -1, we have 3, we have to the 0, we have 3 to the 1, and we have 3 to the 2. Now, as we go through and solve for y, for 3 to the -2, that negative in the exponent tells us we have an inverse. So that means 1 over the base and the exponent positive. Okay, that's 1 over 3 squared, which is 1 over 9. And 1/9 comes out to be 0.111. We'll go to 3 decimal places with these, okay? All right. 3 to the -1 tells me I have 1 over 3 to the first power, or just 1/3. And 1/3 is equal to 0.333. Okay, then we have 3 to the 0 power, and as we talked yesterday, any number times itself, or times any number is itself times 1. And when we have the absence of a number, we still have 1. So 3 to the 0 power is 1. Then we have 3 to the first power, which is 3, and 3 squared, which is 9. All right, let's do some graphing. All right, now for -2, we have 0.111. So we will come slightly above the line and put our dot here. Okay, then we go to -1, and we are at 0.333. So we go about 1/3 of the way up. Oh, there we go. And then we go to 0, and we have 1. And at 1, we are at 3. And at 2, we are at 9. And we try to draw us a nice smooth graph as much as possible. Put the arrows on the end. Okay, so this is about what our graph looks like. Starts out very low, close to the x-axis, and then goes up fairly quickly. Okay, so that takes care of our graph. Now, we need to find the minimum and maximum on the interval of -3 to +3. So let's work these out. We're just going to take the -3. We know that the end posts, those numbers, are where we're going to find our minimum and our maximum. So we're going to just plug it into the equation in the x position. So when x is -3, we have y to the -3rd. That gives us 1 over 3 to the 3rd, which is equal to 1 over 27. And 1 over 27 is equal to 0.037. And that is repeating, but we're going to round to 3 decimal places, so just 0.037. Okay. Now, let's do y equals 3 to the 3rd. Okay. Y equals 3 to the 3rd. 3 to the 3rd is equal to 27. Okay, so 0.037 is on the low side, so that is our minimum. And 27 is on the high side, that is our maximum. Okay. And that looks like that takes care of everything you've asked for. All right, next we have the section 4 through 7. It says, without graphing, determine whether the function represents exponential growth or decay. Okay, so let's look at number 4 to begin with. Number 4 says y is equal to 3 times 7 to the x power. Okay, remember, as long as, let's come over here, let's change colors. If for y equals a times b to the x, as long as a is greater than 0 and b is greater than 1, then we have exponential growth. Right? And if a is greater than 0 and b is between 0 and 1, then we have exponential decay. Okay, or it decreases. Okay? So, where we're going to look to see if we have exponential growth or decay is in our b. Okay? So if I look at b, b is 7. So that's greater than 1. So that means b has exponential growth. Okay. Let's look at one more. Let's look at 6. Y is equal to 0.5 times 0.2 to the x power. Okay, again, we are looking at b, not at the a. Okay, so when I'm looking at b, that is bigger than 0, but it is less than 1. So this is exponential decay. All right, and that is all for that section. Just finish out the rest of them, and we'll check those tomorrow. All right, let's look at number 8, 9, and 10. It says, find the y-intercept of each function. Okay, we're going to look at number 8 and number 10. Do number 9 on your own. Okay, now, remember that we said that the y-intercept is equal to a. So that means 0, a. Okay? So 0, a is our intercept. So we're going to look y equals a times bx, right? So we're going to look at the a. So we're looking right here in front of that. Okay? Now, y equals 2 times the 0.75x, or to the x. And we're looking at the a. My a is 2. So my y-intercept is 2. Or you could put it as 0, 2. Okay. Number 10. We look. Now, originally our equation was just y equals 3 to the x, right? It didn't have a 1 in there. But we know that when we don't have anything in front of a number, then it's just 1, right? So all we had was y equals 3 to the x. Now, I can say with confidence that there is a 1 multiplied in front of that 3 to the x power. So we're going to use that 1 as our intercept. So our y-intercept is 1, or 0, 1. Okay? All right, do number 9 on your own. All right. The next section says for each annual rate of change, find the corresponding growth or decay factor. Now, you know y equals a to the bx. B is equal to 1 plus the rate of change, right? And that rate of change is what we're looking for, okay? And when we add that rate of change to that 1, that ends up giving us our growth or our decay factor. So let's look at number 11, and then we'll look at number 12. Okay, number 11. So B is equal to 1 plus the rate of change. In this case, it's 35%. So 35% when we change it into decimals is 0.35. So that ends up giving me 1.35 as a rate of change. Okay. Then let's look at number 12. Number 12 is a little different. This one is a negative, and we have talked about that some in the last lesson for 7.1, or for during the lesson when we were taking notes, when we were doing the Iberian links problem. So B in this case is 1 plus a negative number, which is negative 0.2. Okay, and that should look kind of familiar. So 1 plus negative 0.2, or 1 minus 2, or 0.2. So when I subtract 1 minus 0.2, I end up with B is equal to 0.80, okay, or 0.8. So 80% is our decay factor. Okay, all right, good deal. All right, let's look at number 14 real quick. It says, identify the meaning of the variables in the exponential growth or decay function. And as you know, our function is a to the t, or the amount over the specified amount of time, is equal to a times 1 plus r to the t power. And it wants to know, what does A and R and T represent? Well, A represents our initial amount. Okay. R, that is equal to our rate of change. Okay. And T, that is our time. And that's all we got to do there. Alrighty. Let's look at number 16. Okay, number 16 says graph each function, then identify any asymptotes and the minimum maximum value on the given interval. So number 16 says y is equal to 0.3 to the x with an interval of -2 to 2. Okay, so we've made ourselves a little t-chart here, and we're going to work out the y values for each of the x values. So when I have x is -2, that means I have 0.3 to the -2, and when I put that in my calculator, it gives me 11. Oops, let me back that out. There we go. 11.111. Okay. Then 3 to the -1 comes out to be 3.333. 3 to the 0, as we've said, is 1. 0.3, excuse me. 0.3 to the +1 is 0.3. And then 0.3 squared is 0.09. All right, so let's take a look at these. Let's get us some points in here that we can graph. All right, we're going to start out at -2. We go to 11.111. So 1, 2, 3, 4, 5, 6. Oops. Let's try that again. Ooh, I'm writing on the gel. Now it won't. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and slightly above 11 right there. Okay, at -1, we have 3 1/3. So -1, 1, 2, 3, and about 1/3. So about right there. Yeah, that works. Okay, and then at 0, we know we have 1. Let's get that a little bit more on point. There we go. And then at 1, we have 0.3, so about 1/3. There we go. And then at 2, we have almost 1/10, so we're just barely above the line, right about there. Okay, and draw us in our curve. There we go, and it flattens out going towards 0. All right, so now we've got our graph, and it starts out up high on the left and comes down real low on the right going towards 0. Okay, so our maximum is going to end up on the right side, it looks like. So let's look at our interval real quick. Our interval is -2 to +2. Oops, come on. Okay. So our high point is on the left. Our low point is on the right. So that means my minimum is on the right side this time. That means this at 2 is my minimum. My minimum is 0.09. My maximum on the left is at -2, so my maximum is 11.111. And my line of symmetry right here at y equals 0, my x-axis. So my line of symmetry is y equals 0. Okay? All right, we're going to do 3 of the word problems, and I'm going to do some that are for regular, some that are for advanced. So if this is one that's not one of the problems you had to do, don't worry about it, okay? But let's take a look, and always kind of watch what other people are having to do too, because that gives you a little bit of extra heads up for working on different problems. So let's start off. Let's do number 19. Let's talk about number 19. Number 19, we've got to write an exponential function that models the situation and then find each amount after that specified amount of time. So number 19 wants us to take a population of 1,236,000 and grow 1.3% per year for 10 years. So we're going to use that formula, a times 1 plus r to the t. Okay, so we have y is equal to 1,236,000 times 1 plus, and then our rate of change is 1.3%. So when I put it in decimals, it's 0.013% for 10 years. So 1,236,000 times 1.013 to the 10. Oops. Okay, and I'm going to put this over here in my handy-dandy little calculator on my phone. Thank you very much to Wabbit Emu. Okay. And we are going to, and if you've got Apple, I did find some stuff for Apple that seems to be working okay, so come talk to me if you need to. All right, we have 1236000 parentheses 1.013 parentheses. Use my caret to get up into the exponents and put 10 in. And I end up with a final population of 1,406,413 people, approximately. Okay? Not bad. This is exponential growth. Okay? All right, let's talk about number 21. Okay, this one is an advanced problem, but that's okay. All right, the value of a piece of equipment has a decay factor of 0.80 per year. After 5 years, the equipment is worth $98,304. What was the original value of the equipment? Okay, well, let's see. So, we have after 5 years, it cost $98,000, or we had a value of $98,304. We don't know our initial rate. Our decay factor is 0.80 to the 5th power because of 5 years. Okay, so I'm going to take, and I'm going to first figure out what 0.8 to the 5th power is. 0.8 to the 5th power is 0.32768, and if you just take that to 3 digits, that would be fine. I'm going to go ahead and leave it in this right here. Well, I'm going to do one over here too. 98,304 is A times 0.32, and we round that to 8. We'll see what the difference between the two is. Okay, to solve for A, I'm going to divide by what's in my parentheses. So 0.32768 or 0.328. Okay, so we end up either A is equal to this or A is approximately this. So 98,304 divided by 0.32768 gives me $300,000 as a beginning price. If we rounded that, 98,304 divided by 0.328, that ended up giving us $299,707.32. Okay, so having it all the way out to the 5 digits did give us a more exact price of $300,000. As we rounded it, it knocked almost $300 off of that original price. Okay, so the 300 is probably more where we're going. Okie doke. Alrighty, let's go on to one more, and we might do one more, or we might do 2 more. Okay, let's look at number 22. Let's get some different colors. Let's go orange. Okay, so number 22. All right, number 22. Your friend drops a rubber ball from 4 feet. You notice that its rebound is 32.5 inches on the first bounce and 22 inches on the second bounce. First of all, it asks what exponential function would be a good model for the height of the ball, and how high will the ball bounce on the fourth bounce. Well, let's talk about this. Now, we have a times t is equal to a times 1 plus r to the t. Okay? So, we know that we have r is equal to y2 minus y1 over y1. Or you might even say b1 for bounce, b2 minus b1 over b1. If you want to go with bounces, either way. Okay? So, what we came up with is we had, for the second bounce, we had 22 inches. And we had 32.5 inches on the first bounce. Divide that by the initial bounce, 32.5. So that gives us 22 minus 32.5 is negative 10.5 divided by 32.5. And we're going to divide that by 32.5. And that gives us a rate of negative 0.323. Okay, so let's go with just 2 decimal places on that. So negative 0.32. Okay, so let's come up here. A to the t is equal to a, and my initial bounce is 32.5. And we've got 1 plus negative 0.32. I'll make that a little bit neater. Negative 0.32. Okay, to the fourth bounce. Okay, so y is equal to 32.5 times, and then 1 minus 0.32 is 0.68 to the fourth. Okay, actually, fourth bounce, let's see, I don't know that we want to call that the fourth. We may want to call that the third, because the first bounce was our initial bounce, so that was the 0 point, okay? So that was our initial input. So between the first bounce and the fourth bounce, that's actually 3 bounces. So we're going to go to the third. Okay, so y is equal to 32.5, and then 0.68 to the third power gives me 0.314432. Okay. Oops. And I multiplied that by 32.5. And I get 10.2 inches on the fourth bounce. Now, if we were to round that to 3 decimal places and do 32.5 times 0.314, 32.5 times 0.314 would give me, again, y would be 10.2 inches. It's off just by a fraction of an inch. Okay. All right. That was... Okay, so the part A, here was our equation. And then our part B was the height of the bounce on the fourth bounce. Okay? And then let's look at number 23, and this will be our last one. Number 23 says a new truck sells for $29,000 and it depreciates 12% each year. What's the value of the truck after 7 years? Okay. Again, here's our formula. Okay. So y is equal to, our initial value is $29,000. 1 plus our rate of change. My rate of change says it depreciates. Depreciates means that it goes down, so it's negative. So negative 0.12. 12% is 0.12. Okay. To the, what year? 7 years. So to the 7th power. So y is 29,000 times 0.88 to the 7th power. 0.88 to the 7th power is y equals 29,000 to the 0.40, and we're going to go ahead and round it to 3 decimal places. So 0.409. Okay, so y is equal to 29,000. Oops, let's get that right at there. 29,000 times 0.409 gives me $11,861 after 7 years. All right, guys. That pretty much goes through every type of problem on your homework. Hopefully this gets to you early enough tonight. It is 5:03 right now, so I'm fixing to post this stuff to YouTube and Facebook, and you have a good night. If you need something, just respond on Facebook or send me a text at 254-592-5547. Give that to you again. Mrs. Woodrush. Two 592-5547. All right, y'all have a good night. Bye.